Hi Hayder, I'm Chaitanya and I'll be doing the presentation for my group. And here's the introduction. As we can see, we have taken the dataset from Kaggle. It's about the health insurance charges based upon an individual's demographic details. So we have variables such as age, sex, BMI, children, and he or she is a smoker or not. So in this project, we are aiming to predict the insurance charges based upon their own demographic details. So before going there, we have done some visualizations and we have found the descriptive statistics and everything. So here is the data visualization for the continuous independent variables age and BMI. As we can see, there is a slight linear trend, even though it's not too significant. There is a slight trend though. And here is the visualization for the categorical independent variable, and here are our descriptive statistics. As we can see, the mean of our target variable, that is charges, is coming out to be 13,270.4. So we'd like to check for this value using Bayesian analysis. So for that, we have given this model, and here we are assuming our target variable to be distributed normally with parameters mu and tau, and again mu is distributed normally with a very low precision, which means it has very high variance. That is because we assume that we don't have any prior information, so that's the reason for it. And here is tau. It is assigned to standard deviation 1 by sigma square, and again sigma is distributed uniformly. And here are our chain settings for MCMC. So here are our diagnostics for mu and sigma. So this is for mu. As we can see, the chains are well mixing. There is no autocorrelation. The string factor is less than 1.1, which is good, and the density plots are merging really well. So, and here it's for sigma. As we can see, it's right as well. And here are the posterior inferences. And as we can see, the mu value is 13,300, which is different from our descriptive statistic. So that is because of the Bayesian analysis. And now going to the multilinear regression analysis. So here we are assigning our target variable to be distributed with a t-distribution with parameters nu, mu, and 1 by sigma square. And each of the parameters are again in turn given their own distributions. Here the mu is assigned a value with betas in form of betas, wherein our betas are again distributed normally with their respective parameters. So here are the steps for the analysis. We are assuming our priors to be non-informative, hence we'll be setting our betas with a very high variances while assigning our prior information. And also we have 3 categorical independent variables, hence we won't be standardizing our data for these particular variables. So here is the model string, here is the standardization, here are the prior information settings. So as we can see, the variance we have assigned is really high. That is because we haven't assumed any prior information. That is, there's no prior information, but we'd like to add some more information to make our model seem better, to make it better. So once we improve our prior settings and everything, we can run the model and get the results by the end of 21st. Thank you, Hayder.